Hello everyone. I am Dr. Vikas Maurya, currently working as an assistant professor in the Department of Mathematics at SR University. Today, I am going to start a video lecture series on the topics of numerical methods, okay, which is especially designed for the science and engineering students. So, in the first lecture, we will discuss about algebraic and transcendental equations and bisection methods. Okay, so before we start the algebraic and transcendental equation, let us first understand what is an equation. Okay. So an equation is an expression of the form fx equal to 0. So our goal here is to find the values of x that makes the equation true. What it mean? It means we want to find the value of x such that fx equal to 0. Okay, and such values are called root solutions or zeros of the function. So geometrically we can say that, suppose if we draw the graph of y equal to fx, okay, suppose this is your y equal to fx, then the root alpha is a point where the graph cut or touch the x-axis, because at that point fx equal to 0. So here your root is alpha, okay, because at this point fx equal to 0. Okay, so this alpha is the root of y equal to f. So this is all about the equations. Now what is algebraic equation? So a polynomial equation of the form fx equal to a0 plus a1x plus dot 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 an x की power n equal to 0 is called an algebraic equation. So in this equation, if an is non-zero, then fx is called polynomial function of degree n. Okay, for example, suppose 2x plus 3 equal to 0. So we can write this equation in the form of polynomial. Okay, because so basically this one is the linear polynomial, and second one is the quadratic polynomial, and third one is the cubic polynomial. Okay, so if we have linear polynomial, quadratic polynomial or cubic polynomial, then we can solve them using exact formula. Okay, because for linear polynomial we can directly calculate the value of x, which is minus 3 by 2. Okay, for quadratic polynomial we have quadratic formula, and for cubic polynomial we have cubic factorization. Okay, so if we have linear, quadratic and cubic polynomial, we can directly calculate the roots using these formulas. Okay, but if the degree of the polynomial is greater or equal to 4, then in that case we do not have any exact formula to find the root. Okay, so in that case we will use the numerical method. Okay, now what is transcendental equation? So an equation is called transcendental if it contains the exponential functions, okay, and logarithmic functions and trigonometrical functions like sin x, cos x and tan x. For example, e की power x minus 3x equal to 0. So this function contains the exponential term. Okay, sin x minus x equal to 0, log x plus x equal to 0. Okay, so these all functions are transcendental functions. So again, if fx is of higher degree, like degree is greater or equal to 4, or it involves the transcendental function, then in that case direct method does not exist. Okay, so we need to go through the numerical methods. Okay, so our first numerical method is bisection method. So before we start the bisection method, let us first discuss about one of the most important theorem, which is called intermediate value theorem. Okay, so what is the statement here? So if fx is a continuous function defined on a closed interval ab, and fa and fb are having opposite signs, then the equation fx has at least one real root or odd number of roots between the interval ab. So what it means? So let suppose fx is a continuous function defined on closed interval ab, and fa and fb are having opposite sign. Means two conditions arises here. One is, suppose fa is less than 0 and fb is greater than 0. Okay, fa is less than 0 means okay. Second condition is, suppose fa is greater than 0 and fb is less than 0. Okay, so in both the cases roots are having opposite sign. Okay, so by the intermediate value theorem we can write fa into fb is less than 0, or in both cases we have fa into fb is less than 0. Okay, so by the intermediate value theorem we can say that the equation fx has at least one real root between the interval ab. Okay, means there exists at least one alpha belong to ab such that f alpha equal to 0. In the second case, there exists at least one c belongs to interval ab such that fc equal to 0. Okay, so we can understand it using the graphical approach. Okay, so first let us define a continuous function on closed interval ab. Okay, suppose this is your function defined on closed interval ab. This is your a, suppose this is your b. Okay, so what is this point? This point is a and fa, and this point is b and fb. Okay, so this is basically the graph of y equal to fx. Now this function is continuous defined on closed interval ab. Okay, and here fa is less than 0 because fa lies below the x-axis. Okay, this is your x-axis, this is your y-axis, and fb is greater than 0 means fb lies above the x-axis. Okay, so here roots are in opposite sign, so means there exists at least one alpha here such that f of alpha equal to 0. Okay, similarly we can define, suppose this is your function y equal to fx defined on closed interval ab. Okay, so this point is a and fa, and this one is b and fb. Okay, so in this case fa is greater than 0 and fb is less than 0. Okay, so means from the intermediate value theorem, here fx is continuous defined on closed interval ab, and fa and fb are having opposite sign, then there exists at least one c in the interval ab such that fc equal to 0. Okay, so this is all about the intermediate value theorem. This is the another form of intermediate value theorem. So what is the statement here? So let fx is a continuous function defined on closed interval ab, and if k is any real number between the fa and fb, then there exists at least one c belong to open interval ab such that fc equal to k. Okay, so what it mean here? So let us define a graph. Suppose this is your graph of y equal to fx. Okay, and let us define a closed interval a b. Okay, this is your a, this is your b, and this point is a and fa, and this point is b and fb. Okay, now here fx is continuous in the closed interval ab, and suppose k is any real number. So what is this point? This point is your fb, this point is your fa. Now if k is any number lies between the interval fa and fb. Suppose k is lies between fa and fb, then corresponding to this k there must exist a point alpha such that f alpha equal to k. Okay, and alpha is lies between the interval a and b. Okay, so this is the another form of intermediate value theorem. Now let us understand the intermediate value theorem using one example. Okay, so what is the example here? The question is there any solution to fx equal to x की power 5 minus 2x cube minus 2 equal to 0 between x equal to 0 or x equal to 2? Okay, so we can use here intermediate value theorem, and okay, so we can use here intermediate value theorem by checking the sign of function at x equal to 0 and x equal to 2. Okay, so at x equal to 0, okay, so what is the function value at x equal to 0? It is 0 to the power 5 minus 2 into 0 cube minus 2 equal to minus 2. Okay, so at x equal to 0, f0 equal to minus 2, which is negative quantity. Okay, and at x equal to 2, what is f2 here? f2 is 2 to the power 5 minus 2 into 2 cube minus 2. Okay, equal to, this is equal to 14. Okay, so which is greater than 0. Now at x equal to 0, the function value is less than 0, and at x equal to 2, the function value is greater than 0. Okay, means here f0 is less than 0 and f0 is less than 0 and f2 is greater than 0. Okay, so here since the given function is polynomial, okay, so this function is always continuous and roots are lies in opposite sign, so by the intermediate value theorem we can say that at least one root lies between the interval 0 and 2. Okay, so by the intermediate value theorem we can directly imply at least one root lies between the interval 0 to 2. Okay, now we will discuss about the bisection method. Okay, so this is the algorithm of bisection method. So what is the algorithm here? So let fx is a continuous function defined on closed interval ab such that fa and fb are having opposite sign, that is fa into fb is less than 0. Okay, so by the intermediate value theorem we can imply that at least one root lies between the interval ab. lies in interval AB. Now if we have the interval AB, okay, so we can take the initial approximation x naught equal to a plus b divided by 2. So what is x naught here? X naught is your initial approximate root. Okay, and how to obtain x naught? X naught is basically the midpoint of interval AB. So this is your initial approximate root. Okay, now if x naught is your initial approximation, then one of the following three conditions arises for finding the first approximation x1. Okay, so first condition is if f of x naught equal to 0, then x naught is your exact root. Okay, if f of x naught equal to 0, then x naught is your exact root. And if f of x naught is non-zero, means either f of x naught is greater than 0 or f of x naught is less than 0. Okay, now we have to check the condition. If fa into f of x naught is less than 0, then the root lies between a and x naught. Okay, then if we have the interval a and x naught, we can calculate the first approximate root x1 equal to a plus x naught divided by 2. Okay, so what is x1 here? Is your first approximate root. Okay, and how to obtain x1? X1 is the midpoint of a and x naught. Okay, and third condition is if the root lies between x naught and b, means fb and f of x naught is less than 0, then your first approximation x1 equal to x naught plus b divided by 2. Okay, and we have to continue this process until the root is found with desired accuracy. Okay, so this is also basically what we are doing here. Okay, if you see, then we are calculating x naught, x1, x2, x3 dot xn. Okay, so basically now we have the sequence of approximate root. Okay, now if suppose alpha is the exact root, suppose if alpha is the exact root of fx equal to 0, then this sequence converges to the alpha. Okay, after some finite number of terms. Okay, so this is the concept of bisection method. So the flow chart is given here. So first we have to start and find the interval. We have to find the interval AB. Okay, for given x. Okay, now if we have the interval AB, we have to check the condition fa into fb is less than 0 or not. Okay, so if fa into fb is less than 0 means roots are having opposite sign, then we can find the midpoint x naught equal to a plus b divided by 2. Okay, now if we have x naught, now check the function value of at x naught. If f of x naught equal to 0, then stop here. Okay, because x naught is now your exact root. Okay, but if f of x naught is non-zero, then select a new interval. And how to select a new interval? We have two conditions. One interval is a x naught and another one is x naught and b. So either root lies in this interval or in this interval. So if root lies in this interval means fa into f of x naught is less than 0, then your first approximation x1 equal to a plus x naught divided by 2. And if the root lies between in this interval means f of x naught into f of b is less than 0, then your first approximation x1 will be x naught plus b divided by 2. Okay, now we have to repeat this process until the root is found with the desired accuracy. So now let us discuss one example to understand the procedure of bisection method. Okay, so apply the bisection method to find the root of equation fx equal to x की power 4 plus 2x cube minus x minus 1. So your function is given here. Okay, so first we have to find the interval AB, okay, where the root of this equation lies. Okay, so if we put 0, then f0 equal to -1, and if you put x equal to 1, then we have f1 equal to 1. So means f of 0 is less than 0 and f of 1 is greater than 0. Means by the intermediate value theorem, root lies between the interval 0, 1. Okay, now if we have interval, so we calculate the first iteration, initial approximation by dividing so x naught equal to a plus b divided by 2, means 0 plus 1 divided by 2, which is equal to 0.5. Now check f of x naught is 0 or not. So here f of x naught means f of 0 is again less than 0. Okay, means the root lies between 0.5 and 1, because f of x naught is less than 0 and f of b is f of 1 is greater than 0. Okay, means root lies between 0.5 to 1. Okay, now if we have new interval, we can calculate the first approximation, okay, by dividing the interval. So your first approximation x1 equal to 0.5 plus 1 divided by 2, okay, and the value is 0.75. Now again, if we put x equal to 0.75, we have negative value. Okay, so f of 0.7 is less than 0, f of 1 is greater than 0, means root lies between 0.75 and 1. Okay, now if we have new interval, we can calculate the second approximate root by dividing the interval, by taking the midpoint of this interval. Okay, so x2 is 0.7 plus 1 divided by 2, which is 0.875. Now again, if we calculate the value of function at this point, okay, now this function is positive. Okay, so at 0.875 it is positive and 0.75 it is negative. Now means root lies between 0.75 and 0.875. So now if we have new interval, we can calculate the third approximation by taking the midpoint of this interval. Okay, so x3 is 0.8125. Now if we calculate the sixth and seventh approximation, means x6 and x7, then x6 equal to 0.8672 and x7 equal to 0.8633. Okay, now this root x7 is correct up to 2 decimal places. Okay, because this root match with the previous one up to 2 decimal places. Okay, means first 2 decimal places have been stabilized. Okay, hence this root 0.8633 is correct up to 2 decimal places. Okay. Now let us consider another example. So here fx is the transcendental function. Okay, so fx equal to x e की power x minus 1 equal to 0, and we want to find the root of this function using the bisection method. Okay, so first we need to find the interval ab where root of fx equal to 0 lies. Okay, so your fx is given x e to the power x minus 1. Okay, so first we will calculate the interval ab. Okay, so let us put x equal to 0 here. Suppose x equal to 0, so f0 equal to 0 into e to the power 0 minus 1, which is e to the power 0 equal to 0. So this is equal to minus 1, which is a negative quantity. Okay, and if we put x equal to 1, then we have 1 into e to the power 1 minus 1. Okay, so which is equal to e minus 1. Okay, now this value is approximately equal to 1.718, which is a positive quantity. Okay, so here f0 is less than 0, f1 is greater than 0, means roots this function is again continuous. So means by the intermediate value theorem we can say that at least one root lies between the interval 0, 1. Okay. So if we have interval, we can calculate the initial approximation x naught by taking the midpoint of this interval. Okay, so x naught equal to 0 plus 1 divided by 2, so it is 1 by 2. Now we will check the function value at x naught. Okay, now f of 1 by 2 equal to, it is 0 to 0.5 e to the power 0.5 minus 1, which is equal to approximately minus 0.176, which is a negative quantity. Okay, now at 0.5 the function value is negative, and at 1 the function value is positive, means next interval will be 1 by 2 and 1. Okay, so if we have new interval ab, then we can calculate the first approximation x1 equal to by taking the midpoint of this interval. Okay, so this is 1 by 2 plus 1 divided by 2, which is equal to 0.75. Again we will check the function value at 0.75. Okay, which is equal to 0.588. okay, which is greater than 0. Okay, now at 0.75 it is greater than 0, and at 1 by 2 it is less than 0, means your next interval will be 0.5 and 0.75. Okay, now if we have new interval, we can calculate the third approximation x3. x3 is by taking the midpoint of this interval. Okay, 0.5 plus 0.75 divided by 2. So we have x3 equal to 0.625. Okay, so similarly if you calculate the sixth and seventh approximation, means if you calculate x6, then you will get 0.57825, and x7 equal to 0.570312. Okay, now x7 root, this root is correct up to 2 decimal places, because this one is matched with the previous root up to 2 decimal places. Okay, so first 2 decimal places have been stabilized. Okay, so this is all about the bisection method. Okay, so this is all about from my side. If you have any doubt or suggestions, then you are free to write in the comment box. Okay, thank you everyone for watching this video. Thank you.